Electronegativity Part 1 video we discussed in detail meaning of electronegativity and polarity with plenty of examples. We also did difference in electronegativity and electron affinity. In electronegativity Part 2, we discussed the factors controlling the electronegativity, in which we discussed in detail variation of electronegativity with atomic size and variation due to closeness to the noble gases in the periodic table. In electronegativity Part 3 video, we did range of electronegativity on the Pauling scale. Which element has the highest value of electronegativity? Which element has the lowest value of electronegativity? And based on the difference in electronegativity, different types of bonds are identified: polar bond, non-polar bonds, and ionic bonds. In electronegativity Part 4, following topics are covered with examples and practice problems: variation of electronegativity with hybridization of atom, with oxidation numbers, with formal charges, and due to difference in electronegativity, we will understand movement of electrons during resonance and during chemical reactions. Electronegativity changes with change in hybridization of the atom. In organic molecules, carbon atom can undergo hybridization of sp3, sp2 and sp. sp3 hybridized orbitals are formed by mixing 4 orbitals. One orbital is s orbital and remaining 3 orbitals are p orbitals. In sp2 hybridization, it is formed by mixing 3 orbitals, 1s and 2p's. sp hybridized orbitals are formed by mixing only 1s and 1p. So it is formed by mixing only 2 orbitals. More is the number of orbitals mixed for hybridization, more bigger is the size of the hybridized orbital. So it means that sp3 orbitals are more bigger in size than sp2, which are more bigger in size than sp. As we know that electronegativity changes with the change in size of the atoms for the orbitals which are participating in chemical bond. In case of bigger orbitals, the shared pair of electrons move away from the nucleus of the hybridized atom. So in sp3, distance between the shared pair of electrons and the nucleus is very large, whereas in sp, the shared pair of electrons are very close to the nucleus. So attractive forces on the shared pair of electrons will be highest in sp hybridized atoms. So it means sp hybridized atoms are more electronegative than sp3 or sp2. This is because of the orbital size order. sp orbitals smallest and hence closest to the nucleus, so they have maximum electronegativity value. So the electronegativity order based on orbital size is sp more electronegative than sp2, which is more electronegative than sp3. Now we will use this concept in solving the polarity of many carbon-carbon bonds in organic compounds. Let's see which carbon atom in this molecule is going to be most electronegative. We have 5 different carbon atoms, and to know which carbon atom is more electronegative, we will work out their hybridization in the molecule. We can easily predict hybridization by calculating the number of sigma bonds and the lone pairs on the central atom. You can use this general formula. Hybridized orbitals are used only for making sigma bonds and for holding lone pairs. They are never used in making pi bonds, and pi bonds are formed by pure p orbital. So when we check every atom, we will count how many sigma bonds and lone pairs are there. Let's start working with carbon number 1. On carbon number 1, there are 2 sigma bonds with 2 hydrogen atoms and 1 sigma bond with carbon number 2. Double bond between carbon number 1 and 2 is not counted because it is formed by overlapping of the pure p orbitals. It means on carbon number 1 we have 3 sigma bonds, so we need 3 hybridized orbitals. And sp2 hybridization gives us 3 hybridized orbitals. We can calculate this by using this given equation. Here n is the sum of number of sigma bonds or atoms and lone pairs. In this case, n is 3. 3 minus 1 is 2. So the hybridization is sp2. Now let's take carbon number 2. There is 1 sigma bond with carbon number 1, 1 sigma bond with carbon number 3, and there is 1 sigma bond with hydrogen. Hydrogens are not shown here because this is line notation. So carbon number 2 has again 3 sigma bonds. So it means it needs 3 hybridized orbitals, which means sp2 hybridization. Okay, now carbon number 3. It has 2 sigma bonds with 2 hydrogens, 1 sigma bond with carbon number 2 and 1 sigma bond with carbon number 4. So in total there are 4 sigma bonds. It means 4 hybridized orbitals are needed. So it is sp3 hybridized. Carbon atom 4 has 1 sigma bond with carbon number 5 and 1 sigma bond with carbon number 3. And rest 2 bonds are pi bonds, which are made by using pure p orbitals. So it means it has only 2 sigma bonds. So it needs only 2 hybridized orbitals. So it is sp hybridized. Similarly, carbon number 5 is making 1 sigma bond with hydrogen, 1 sigma bond with carbon number 4. Rest 2 are pi bonds. So it also needs only 2 hybridized orbitals. So it is also sp hybridized. Now which carbon atom is the most electronegative? sp. sp carbon is the most electronegative atom because it has the smallest orbital. So it means carbon number 4 and carbon number 5 are most electronegative atom. And now which bond is going to be the most polar in nature in the given compound? It is the one with the highest difference in the electronegativity, and that is carbon number 5 bonded with hydrogen. That carbon-hydrogen bond is highly polar in nature. There is a partial negative charge on the carbon and a partial positive charge on the hydrogen. This hydrogen, which is bonded to sp carbon, is also very acidic in nature in comparison to other hydrogens which are present in this molecule on sp2 and sp3 carbon. For doing this type of questions, we have to understand the meaning of more polar bond and how to identify it in a given compound. More polar bond is the one in which the difference in electronegativity between the bonded atoms is the maximum. Let's try to work out this with the help of an example. A is bonded to H and B is also bonded to H. The difference in electronegativity of A from H, let's say, is 2.0. So the difference in electronegativity of B and H, let's say, is 0.5. So where is the difference in electronegativity more? In A and H bond. So it means this bond is going to be more polar. There is more charge separation than B and H bond. There is charge separation in B and H also, but due to less difference in electronegativity, there is less charge separation and hence less polarity. there is more charge separation in A and H bond. So this is going to be more polar bond, and this hydrogen is going to be more acidic in nature, the one which is bonded to more electronegative atom. So that's the criteria or the basis of identifying more polar bond and more acidic hydrogen. So what is needed when we are doing these type of questions? First, identify the most electronegative atom. If the atoms are identical, then check their hybridizations. Remember, the one which is sp hybridized is going to be more electronegative than sp2, which is going to be more electronegative than sp3. Let us start with molecule 1. In molecule 1, we have nitrogen, carbon and hydrogen atoms. Nitrogen is smaller in size than carbon atom. So nitrogen is more electronegative than carbon. Hydrogen is even less electronegative than carbon. So it means in this molecule, nitrogen is the most electronegative element. Now we have two nitrogen atoms. So we have to compare their hybridizations. On this nitrogen, there are 3 sigma bonds and 1 lone pair. So it is sp3 hybridized because it is in need of 4 hybridized orbitals to accommodate 3 sigma bonds and 1 lone pair. And in this nitrogen, there are 2 sigma bonds and 1 lone pair. So we need 3 orbitals to accommodate 2 sigma bonds and lone pair. So it means this nitrogen is sp2 hybridized. So which hybridized nitrogen is more electronegative? sp2. sp2 nitrogen is more electronegative than sp3 nitrogen. It means this nitrogen bonded with hydrogen is more polar in nature. So hydrogen B is more acidic because it is bonded to more electronegative nitrogen atom. Now let us see the second example. In this example, we have only carbon and hydrogen atoms. So which atom is more electronegative? Carbon is more electronegative than hydrogen. But there are many carbon atoms. So we will compare their hybridization. The carbon which is present in the aromatic ring, all these carbon atoms are sp2 hybridized. They all have 3 sigma bonds around them. This carbon has 4 sigma bonds around it. 1, 2, 3, 4. So it is sp3. Next carbon atom has only 2 sigma bonds. So it is sp hybridized. The last carbon also has only 2 sigma bonds. One with carbon and the other with hydrogen. So it is also sp hybridized. So which carbon is more electronegative? sp carbon is more electronegative. But there are 2 sp carbons. One sp carbon is bonded only to carbon atoms, no hydrogen on it. Second sp carbon is bonded to hydrogen atom. So this particular chemical bond will have the highest difference in electronegativity and is also the most polar bond in this given molecule. So this hydrogen A is the most acidic hydrogen. Electronegativity changes with change in oxidation number of the central atom. And this change in oxidation number and electronegativity has a very strong effect on the mechanisms of the chemical reaction and the acidity of hydrogen in organic compounds. This topic becomes very important to answer many questions based on curved arrow mechanism and acidity of the hydrogen. In this series, the central atom chlorine has different oxidation numbers. In the first case, it is +7. Second chlorine is +5 and third is +3. The last one has +1 oxidation number. Now, which chlorine is more electron hungry? The one with +7, very high positive charge. Oxidation number very high is very electron deficient. It means it has more tendency to pull electron density on itself. It means it is more electronegative. So if we compare chlorine atoms with +7 with chlorine atom of +5, +3 and +1 oxidation number, chlorine with +7 is the most electronegative because it is the most electron deficient. Chlorine with +1 is the least electronegative because it is the least electron deficient in the given series. Now let's see how this change in oxidation number and electronegativity changes the acidity of the hydrogen bonded with oxygen. Now chlorine with +7 oxidation number, which has the highest tendency to pull electron density on itself, withdraws electron density from the oxygen, which in turn withdraws electron density from the hydrogen. So the release of this hydrogen is more easier as compared to the release of hydrogen in +5 oxidation number, which in comparison with +3 is more easier or more acidic, and in +3 oxidation number it is more easier to pull out this hydrogen as acidic hydrogen than in +1, which has the least electronegative chlorine atom of the given series. It means as we go from lower oxidation number to higher oxidation number, acidity increases. So, perchloric acid is the strongest acid with highest oxidation number on the chlorine atom. This is stronger acid and it has a very low pKa value. Hypochlorous acid with +1 oxidation number of chlorine atom is the weakest acid of this series with highest value of pKa. So we can see that higher oxidation number, higher is the electronegativity, more is the acidity. More acidity means high value of Ka, which means low value of pKa. Remember, Ka is the acid dissociation constant, and strong acids have more dissociation, so higher value of Ka. And pKa is a negative log of Ka. So high Ka value means low pKa value. Let us do one question based on difference in electronegativity due to difference in oxidation number in the given organic molecules. The question is, which hydrogen is the most acidic hydrogen in the given organic compound? We'll start with working out the oxidation number of carbon atom in every molecule. In first molecule, carbon is -2 in oxidation number. In second, it is 0. These are the oxidation number of carbons. And in third, it is +2. Which carbon has the highest oxidation number? The carbon in third molecule. So it means the carbon of third molecule is the most electronegative atom and has the highest tendency to pull electron density from the hydrogen. So this hydrogen is going to be most acidic. We can understand this concept in other way also. Like here we have 3 chlorine atoms bonded to carbon atoms. Chlorine is more electronegative than carbon. So they withdraw electron density from carbon and making it highly electron deficient. Due to this, electronegativity of carbon increases many folds and it will pull electron density from the hydrogen atom. As a result of this, hydrogen is most acidic hydrogen because it is bonded to the most electron deficient carbon atom. As the number of chlorine atoms bonded to carbon atom increases, oxidation number decreases. Electronegativity of the central atom decreases, and hence tendency to pull electron density from the hydrogen bonded to it is also decreases. So acidity. Electronegativity depends on the formal charges also. If there is an electron deficient atom which has less than 8 electrons or which has a formal positive charge on it, those atoms are going to be more electronegative than neutral atoms. Let's try to understand this with different examples. In ozone molecule, we have 3 oxygens. The oxygen with formal positive charge is more electronegative as it is more electron deficient. The one with negative charge is more electron rich and is the least electron deficient. So least electronegative. The third one is without any formal charge on it. So the one with very high formal charge is the most electron hungry and is the most electronegative and has the highest tendency to pull electron density on itself. Now lone pairs present on the negatively charged oxygen atom means the least electronegative oxygen can move in the direction of positively charged oxygen atom. But positively charged oxygen atom has already 8 electrons on it. So it has no tendency to accommodate 2 more electrons. So the double bond will shift in the direction of neutral oxygen to create space for getting the lone pair as a pi bond. So when we make the resonating structures of ozone molecule, the very big question children are asking, how to start with the first curved arrow? You have to push electron density in the direction of most electronegative oxygen atom from the least electronegative oxygen atom, or in the direction of formal positive charge. Let us work with another example. In this, carbon is electron deficient with a formal positive charge and has only 6 electrons on it. So during resonance, this pi electron density will move in the direction of more electron deficient carbon, the one with formal positive charge. Another example, here this oxygen is more electron rich with formal negative charge, so it will push its electron density on the carbon which has no formal charge on it and is also sp2 hybridized. This carbon here is more electronegative than the oxygen atom which has a formal negative charge on it. So this carbon will take electron density from the oxygen and make a pi bond, but it is already with 8 electrons. So this pi bond will shift on adjacent carbon atom. So you can easily make very first curved arrow in the resonating structures on the basis of difference in electronegativity. Electron pairs move from least electronegative atom, which is electron rich, to most electronegative or electron deficient atom. Thank you for watching this video. In Electronegativity Part 4, following topics are covered with examples and practice problems. Variation of electronegativity with hybridization, oxidation number and formal charges. And then due to the difference in electronegativity, how the electrons are moving during resonance and chemical reactions. If you want to practice more questions on the same concept, please click on the link given below. You are most welcome to ask your doubts or questions in the comment section of this video. In Electronegativity Part 5 video, we will discuss induction and dipole moment, use of electrostatic potential map, prediction of dipole moments with practice problems and a quiz. You can click on the link shown here to go to Electronegativity Part 5. Links to notes and questions have been provided in the description below. Please like, share and subscribe, and do not forget to click on the bell icon to turn on notification.